Let's do our last unit for this 4.9, El Nino and La Nina. So El Nino is the southern oscillation flow, and it's a phenomenon that happens in the Pacific Ocean every so many years. And the weird part is we still have a hard time predicting when it's going to happen and how severe it's going to be. Okay, I'm gonna hope this little video plays. Let's see what happens.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Nino. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern US, and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Nina, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Nina can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Nino and La Nina together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
All right, hopefully you could read that along with me. Okay, so in the ocean, there are these large circles, and these should look familiar because these are convection, just like the wind part. So you can see the cold currents are moving downward, southward on this one, and the warm currents are moving northward. And sometimes they switch below the hemisphere. So depending if you're north or south of the hemisphere, the gyre direction will change. Okay, but this convection will influence how the water moves and how the wind moves as well. Okay, so upwelling is the way fish get their food. So if you are a fish, you live in the pelagic zone, which is actually in the upper part of the water where it's warm and near the sunlight. Fish need food, and then food has a lot of density, so it hangs out at the bottom of the ocean. Fish do not swim down to get their food. They depend on this upwelling action, which kind of sweeps the food up, like these arrows are showing, and brings the food up here where the fish can eat it. Okay, so upwelling supports a lot of populations of the phytoplankton, the plant plankton that do the photosynthesis, the zooplankton, like plankton from SpongeBob, the animal type, fish, and fish-eating seabirds. So upwelling is a huge part of ocean dynamics because that is how the living things get their food. Marine snow is a concept of this is just organic matter and it has more density, so it's sinking slowly down to the bottom. So this marine snow becomes nutrient and it's waiting to be swept up through upwelling. So this is part of the cycle. Okay, so upwellings happen offshore. The surface current moves apart and draws up the water from these deep layers. So here's the surface current blowing things offshore, away from shore, And then these cold, nutrient-rich waters, where all the food gets drawn up, and then fish that are hanging out up here can eat it. So the western coasts are pretty steep. So this is actually part of the continental plate, and it goes into the ocean for a bit. And this steep, steep part right here is the continental slope, still part of the continental crust. And then out here we have the ocean crust from plate tectonics. And so this steep area is where this upwelling needs to come up and be delivered with the nutrients. Okay, so at the equator, this upwelling happens. So this term equatorial upwelling is just upwelling that happens at the equator. And we get these two winds. We get the southern trade winds and we get the northern trade winds. So in our wind unit, at the equator, we had the Hadley cell for wind, but at that 30 degrees north and south, now we have these trade winds. And there's stories in history about the trade winds. If you're a history person, you should probably know about that and why they're called the trade winds. Okay, so we've got this upwelling. The warm surface water splits apart, and this cold water upwells from below. And remember, the cold upwelling has the food, so that's a good thing. Okay, so in normal conditions, even though this says neutral, this is normal oceanic conditions, and this is the Pacific Ocean. So this is, if you can see, this is North America here. This is South America here. This is Australia. And then this would be Asia way over here. And you can see the normal flow. The trade winds are moving to the east. Sorry, I ought to do this before I say the wrong thing. To the west. And as this lifts up, whenever clouds go up, they drop down rain and precipitation. So usually in normal conditions, Asia gets all the rain, and here in America, we get the drought, the dry. We know that in California. We always have a drought. In normal conditions, that's how it works. In normal conditions, this is what the upwelling looks like. I know this is a little blurry, but we have some upwelling happening, so the fish are happy. They're getting their food. Now in the years when El Nino comes, look at the difference. So here is warm temp, and here's cool temp. But look what the difference between a normal year and an El Nino year. First of all, look at the temperature. So it's way warmer water over here and the cool water's over there. So that's a switch from normal. And then look at this wind pattern. We don't just have one nice big wind pattern. We've got these weird split open things going on. So we have this extra convection, and it's doing its own little cycle, and it's moving opposite how it usually moves. Over here it's moving up, and over here it's moving down. Well, remember, when air is moving up, it dumps out all its moisture, but when it's coming down, it's bringing dry air. So now, where they usually have lots of moisture, they get the drought. And where we usually have the drought, we have floods and tons of rain and crazy, crazy amounts of precipitation. So over here, look what happens to upwelling. There is no upwelling. So I used to show a Bill Nye video, and he would always say, in El Nino years, fish die. And he would yell it, but it's true. Fish die. And in an El Nino situation, put a little X through their eye, they're gone. They start dying. All right. So La Nina is an attempt to correct the El Nino year, because the girls always have to fix the guys' mistakes. I'm just kidding. Just kidding. Just kidding. But look what happens. So now this direction of flow is in the normal direction, but look at the thickness of this arrow to this arrow. So La Nina is like major motions of this to try to correct this El Nino situation. So we get this warm stuff pushed over, but it's still quite a bit warmer than normal conditions. So these guys are going to have increased rain. We are going to see cooler situations over here, and we in Southern California, whoops, will see drought. But the Pacific Northwest, like Oregon and Washington, they're going to have a lot more rainfall. And then look at this upwelling. It's like mega upwelling. So the food comes flying in because it's such an extreme upwelling event going on. It's like major convection compared to like normal convection. Okay, so what's going on if you're a note person instead of the visual person? So it happens every few years. It's like 3 to 7 years, and it's kind of like not predictable. So the normal shore upwellings get affected by changes in the weather patterns because the drought turns to rain and the rain turns to drought. So drought and rain kind of switch places. And then those trade winds get weak or sometimes even reverse directions. So remember the trade winds were moving like this, and sometimes they'll be weaker or they'll actually do that weird switch thing like this. And that'll be opposite of what's supposed to happen. And then we get warm water moving towards South America, and that wrecks or suppresses the normal upwellings of cold, nutrient-rich water, so fish die. Okay, so as a consequence, the US, the northern part of the US and Canada are drier and warmer than usual. So look at this little part right here. The US Gulf Coast and Southeast have more rain and cooler temperatures and a lot more flooding. The upwelling weakens or stops altogether. So this is right here, no upwelling. And then think about this. The biomes are all jacked up. So just because this is happening in the Pacific Ocean, it has a worldwide reaching effect. Look at all around the whole world has issues with this. So it's a really bizarre thing, but it affects the whole world. So think about biomes. So if you are in the desert, and it's supposed to be dry and warm, and you get tons and tons of rain, out in these deserts, we get these big flash floods, and that causes a lot of issues. Or if it's supposed to be warm and it's now cool, that's some issues. If it's supposed to be warm but now it's dry, that's a problem. So all these like weather flips kind of throw everything off. Okay, so here's the phenomenon, another way to look at it. So you see the normal view. So this one, you can see the cycling of the water and the temperatures and the winds, how they're changing, how they are normal, and then when it's changing. So look, opposite flow, and there's like this weird split off going right between North and South America. And that's where that upwelling stops. The winds get weaker, and we get this warmth instead of cool. And then just in terms of weather precipitation, we have areas of drought, we have areas of really high rainfall. That's us right there in that little section of blue. And then there's places where it's really warm. So like in these areas, it's hotter than usual. And even the East Coast gets affected by this. So it's just this crazy, crazy thing. That's why it's a phenomenon. We don't really know how to explain it, but we do have patterns and data of all the years that it happens and what's going on. In case you're curious, for the year 2023, it's going to be a La Nina year. So what does that mean? Okay, so again, another inside look. So the thermocline is this temperature in the ocean. And so you know how like when you go in the ocean, the deeper you go, the colder it gets. Well, there's a point where the deeper you go, the colder it gets, but then there's a point where it just stays the same temperature all the time. And so you can see that it changes during the El Nino year. The warmer water is going the opposite way, so that thermocline changes. So this is warmer water for deeper amounts in the ocean. And then we get this split off convection thing happening during El Nino. Okay. La Nina will cool off the surface waters. It'll bring back the upwellings. That's kind of the big job. So thanks. So we should see better fishing this winter of 2022-2023. And like I said, La Nina kind of fixes El Nino. You do get more hurricanes in the Atlantic. You get colder winters in the Northeast, drier winters where we are, Southeast, sorry, and Southwest. We're Southwest, but also in the Southeast. There's more wildfires. California always has a good wildfire going on. Drought in California, nothing new for us. And then the Pacific Northwest, more rain. And then Asia gets torrential rain, like lots and lots and lots of rain, to the point that it's flooding and overwhelming. Okay, I think we saw that already. So the bottom line, this can affect food supply, crop growth, and soil erosion. So if it's too wet, those things get affected. And if it's too dry, those things get affected. So lots of stuff going on, natural disasters, crises, contamination, all kinds of stuff. Okay, so hopefully that gives you a little overview. The things you'll see on the AP test will ask you like in what areas will it be drier in an El Nino year? What areas will it be drier in a La Nina year? So you kind of have to know what changes, and they'll give you some options on the APES test, or they'll ask you about upwelling. So those are kind of the big things to look out for. Okay, we are done with Unit 4. See you on the backside for Unit 5.